You know that feeling, right? You're staring at your screen, maybe trying to wrestle with a tough report or really dive deep into studying. And then, almost without thinking, you reach for your headphones, hovering over your music playlist. Does it actually help you focus? Or is it just like another layer of distraction? What's really going on inside your brain when the music starts? Today, we're doing a deep dive into exactly that. There's this fascinating new study that used, well, a whole suite of advanced sensors to look at working memory, not just with music playing, but with music as an active component. We're not just talking background noise here. It's about exploring music as a potential tool, a non-invasive one, to actually regulate our cognitive states. So our mission today is to unpack how researchers are using this really cutting-edge tech to understand that brain music dance, why it matters for things like, focus and performance, and what surprising insights this kind of multimodal data can offer you. It's a really cool look at how something so common could be key to unlocking our cognitive potential. Okay, let's get into it.
It really is an exciting area. I mean, for ages, music's been seen mostly as, well, aesthetic, right? Something for enjoyment, setting a mood. But the study really highlights how we're moving into an era where we can measure its actual physiological and cognitive effects, measurable ones. It sort of shifts our whole perspective from music as just passive enjoyment to potentially an active intervention.
Active intervention. I like that phrase. Makes you think differently about your go-to playlist, doesn't it?
Yeah.
The idea that music isn't just for fun, but could literally actively change our brain state. That's pretty wild. Not just mood, but like a brain tool.
It is wild, but there's a solid foundation for it. The theoretical underpinning, it goes back to a really fundamental concept in psychology, the Yerkes-Dodson Law. This law basically suggests there's a kind of sweet spot for cognitive arousal, an optimal level where your performance peaks. Think about it. If you're too chilled out, maybe under-aroused, your mind wanders, performance dips. But if you're too stressed, over-aroused, you get overwhelmed, make mistakes, your output drops.
Right. So it's not about being hyper alert or totally zoned out, but hitting that perfect Goldilocks zone, that middle ground. So this study was asking, could music be the thing that helps us find that zone, kind of nudging us towards peak performance?
Precisely. They're looking at whether music can non-invasively help regulate our arousal and performance to get us into that sweet spot. What's really interesting is how they're thinking about using this. It's not just confirming a feeling we have, they're measuring it, quantifying it.
Okay, that immediately makes me think, what does this mean for, just everyday folks trying to focus, or maybe someone dealing with concentration issues, or even like someone recovering from a brain injury? This sounds like it goes way beyond just a productivity tip.
Oh, absolutely. If you look at the bigger picture, this kind of research is really foundational for developing highly personalized ways to regulate brain states without drugs or invasive procedures. Imagine, maybe in the future, a specific music prescription could help a student stay focused during a really complex task, or maybe assist someone in neuro-rehab after a stroke to boost memory. It has huge implications for cognitive impairments and even for designing next-gen brain-machine interfaces that work with our brain's natural rhythms. This isn't just abstract theory. It's got really tangible, exciting applications.
That's genuinely incredible. So to understand how they even started looking into this huge idea, we probably need to get into the details of the experiment itself. They use something called the unpack task. I know that's a classic in cognitive science. Can you break that down for us?
Yeah, the unpack task is, well, it's a standard for a reason. It's a very effective way to measure working memory and cognitive load. So here's how it works. Participants see a stream of stimuli, one after another. In the study, it was single letters. Their task is to decide if the letter they're currently seeing matches the one that appeared and positions before it in the sequence. So for one back, you're just checking against the immediately previous letter. Pretty straightforward. But for three back, you have to remember the letter from 3 steps ago.
Wow, yeah, that sounds mentally taxing. I can feel my brain churning just thinking about 3 back. So increasing the N really cranks up the difficulty then.
Exactly. That's the point. The researchers here focus mainly on 2 levels. 1 back, which is relatively easy. You just hold one item in mind. And then the 3 back, which significantly ramps up the cognitive workload. You're constantly updating what's in your memory, ditching old letters, grabbing relevant ones, all under time pressure. It's designed to push your working memory.
Okay, and this is where the music comes in, right? Participants didn't just listen to random background music. They actually brought their own calming and exciting tracks. That's where it gets really interesting. How did they weave the music into these demanding tasks?
Yes, that personal music choice was really key. The idea was to get genuine emotional and physiological reactions. So the experiment had two main sessions. In one session, people did the unpack tasks while their chosen calming music played. In the other session, same tasks, but with their exciting music. Each session was about 16 minutes long, and it was broken down into several task blocks.
And within those 16 minutes were the easy one-back and hard three-back tasks all mixed up.
Yep, perfectly mixed and randomized. That avoids any bias from doing all the easy ones first, for example. Each 16-minute session had an equal number of one-back and three-back blocks, actually 8 blocks of each, so 16 blocks total per session. And inside each block, there were 22 trials, so 22 letters to respond to. They managed the timing really carefully, too. Short 10-second breaks between blocks, a slightly longer 20-second break halfway through the 16 minutes, and then a proper 2-minute rest after each full session. It was very controlled.
And who are the people involved in this pilot study? I know these deep brain studies often start with a smaller group to collect really dense data.
That's right. They initially recruited 11 participants. But the really comprehensive multimodal data, meaning, where all the different sensors worked perfectly, it gave usable data that came from 5 individuals, subs 3, 4, 6, 8, and 11. It just underscores how complex this kind of research is. You need every single technological piece working just right to get that full picture.
Right, and this is where the tech side just gets amazing. They weren't just measuring one or two things, you said a whole suite of sensors. What exactly were they measuring to get inside that mind-music link?
It really was a symphony of sensors, as you put it earlier, each one playing a crucial part. So first, they gathered a whole array of physiological signals, things like skin conductance, you might know it as EA, electrodermal activity, that's a great indicator of your autonomic arousal, basically how activated or stressed your body is unconsciously. They also had ECG for heart activity, skin surface temperature, respiration rate, PPG photoplethysmography, which tracks subtle blood volume changes linked to heart rate variability, and EMG, electromyogram, measuring muscle tension. So these give you a window into the body's automatic responses.
Okay, so that's the body's sort of background reaction, but they also look directly at the brain, right?
Exactly. That's crucial. For direct brain activity, they used fNIRS, functional near-infrared spectroscopy. This is a really neat piece of tech because it non-invasively measures changes in blood oxygenation in the brain. Essentially, it shows where the brain is working hardest. And fNIRS has some real strengths. It gives better spatial resolution than EEG, so you can pinpoint activity more precisely. Plus, it's portable, which is great for studies like this. It's especially good for looking at the prefrontal cortex, which is super involved in memory tasks like unpack.
And then, obviously, besides all the body and brain signals, you need the bottom line. How did people actually do on the tasks?
Absolutely. That's the behavioral data. It's essential for understanding performance. They tracked every single response, correct, incorrect, and how fast people responded, the reaction time for each letter. And one more thing, they also captured de-identified facial expression scores. So another layer of observable response potentially indicating emotional state.
Okay, wow, that is a lot of data streams. So why? Why go to all that effort? Why strap on so many sensors? Isn't like one signal enough to tell you if someone's stressed or focused?
That's a really good question, and it hits the nail on the head about why this multimodal approach is so powerful. While, yeah, a single signal like skin conductance can tell you something useful, collecting all these diverse signals lets researchers capture complementary aspects of what's happening. It's like each sensor tells a slightly different part of the story. Skin conductance tells you about arousal, fNRS about brain workload in specific areas, reaction time about performance efficiency. Put them all together, and you get a much richer, more complete picture of the brain's overall response to both the cognitive challenge and the music.
Ah, I see. It's like assembling a puzzle, right? Each sensor gives you a different necessary piece to see the whole image.
That's a perfect way to put it. This holistic view can lead to much more robust biomarkers of cognitive states, like stress or focus. You're not just relying on one data point. You're seeing a pattern across multiple systems, physiological, neurological, behavioral. Imagine, you see not just a dip in fNIRS activity suggesting overload, but at the same time a spike in skin conductance and maybe a subtle shift in facial expression towards frustration. That combined signature is a far more reliable indicator of cognitive overload than any single measure could be on its own. It could lead to a sort of stress fingerprint. It helps us build a really deep understanding of the mechanisms at play. Now, it's really important to remember, this was a pilot study, a foundational piece of work, so the sample size was small. But what they successfully showed was the feasibility of using music this way as a safe, non-invasive method to potentially regulate cognitive states. Specifically, they were able to decode arousal levels pretty well from the skin conductance data and performance levels for the behavioral data, which suggests this whole multimodal approach really does hold promise.
Okay, that's still a huge step, showing it's even possible. So, building on that success, what are the really exciting potential applications down the road if we can refine this stress fingerprint idea you mentioned?
Oh, the potential is really quite something. This research genuinely opens the door for highly personalized, non-invasive ways to manage our cognitive states. Think about music tailored specifically to an individual's unique brain responses. Not just calming music in general, but your specific calming music profile. Maybe a personalized audio stream helps a surgeon maintain intense focus during a long operation, or helps a student power through difficult problem solving without hitting cognitive burnout by actively managing their arousal level. And the implications for neuro-rehabilitation are massive, helping people regain cognitive function after injury, plus developing new non-drug treatments for cognitive impairments. It really shifts music from just background sound to potentially a precision therapeutic tool.
A truly personalized brain tuner.
Yeah.
Amazing. But like all pioneering research, especially pilot studies, there are always limitations, right? Things that point the way for future studies. What did the researchers themselves flag as the next steps?
Yeah, and they were very clear about the limitations, which is exactly what you want for good science.
Yeah.
First off, the small sample size, just 5 people with complete data, means you can't generalize the findings too broadly yet. You need more people to confirm these initial signals. Second, they didn't have a control group performing the tasks without any music. So it's harder to definitively say how much of the effect is purely the music versus just doing the task itself.
Right. And the music was personal too, wasn't it? Chosen by the participants. Could that play a role?
Definitely. That was another key point they brought up. Because participants use their own music, there's a big factor of familiarity. Their responses might be tied to memories or existing associations with that music, not just its inherent calming or exciting acoustic properties. And finally, a really important limitation. They didn't collect subjective self-reports. They didn't ask people, how focused do you feel or how stressed are you right now? So a big question for future work is how to blend that subjective lived experience with all this rich objective data to get an even fuller, more human understanding. But even with those limitations, this data set itself is incredibly valuable. It's like a goldmine for other researchers. It provides a solid foundation, lets people replicate the study, maybe with bigger groups or a control condition, refine the methods, and really accelerate our understanding of how music interacts with our minds. It's a crucial first step.
What an amazing journey we've taken today. Seriously, from just the everyday act of putting on headphones all the way to this incredibly complex, dynamic interplay between our brains and music, measured by the symphony of sensors. The core idea is just profound, isn't it? Music isn't just background noise or entertainment. It's a powerful, non-invasive tool that might actually help us fine-tune our brain states, manage our arousal, and boost our performance. Seeing that journey from subjective feeling to objective measurement is really something else. So maybe next time you instinctively reach for your music, whether you're trying to power through a tough task or just trying to relax, pause for a second and consider this. What if that track you choose isn't just setting a mood, but actively shaping your brain's capacity to learn, remember, and perform at its absolute best? What kind of personal in-back challenge are you trying to conquer with your playlist right now? Keep exploring, keep asking questions, and keep diving deep with us.